Okay, I hope you've had a good brief summer so far, and this is going to be our first video of several in which we go over this Unit 3, which is going to be necessary for us to start our pre-calculus so that we'll have time to get to AP Calculus by summer of next year. What we're going to look at first is on the 3A worksheet. We're going to look at the difference between direct variation and inverse variation. And I ask that you record the notes first and think about those before you look at these examples. And what I'm going to ask you here is, of these three examples that I show you, does it demonstrate direct variation, inverse variation, or neither direct nor inverse? On this first example, if you'll notice, the variables are both going up. X is getting larger and Y is getting larger as well. So we're both going up here. Now that alone is not enough for it to be direct variation. You must get a constant quotient or the same number when you divide over and over for it to be direct variation. Let's see if we have that here. 21 divided by 3 is 7. 28 divided by 4 is 7. So is 49 divided by 7. So is 70 divided by 10. So because you get the same quotient over and over, this is in fact direct variation. 7, by the way, is called the constant of variation here, and we'll talk more about that later. For our next example, you'll notice quite the opposite, that the variables are actually going in opposite directions. As X goes up, Y goes down. So this is either going to be inverse or neither. Now, for it to be inverse, we would have to always multiply to get the same number. 2 times 18 is 36, 3 times 12 is 36, 4 times 9 is 36, and 6 times 6 is 36. So we go in opposite directions, and we're always multiplying to get the same number. This is inverse variation. Some people say indirect here, but indirect is the incorrect word. It is inverse. So direct variation, the variables go in the same number, or the same direction rather. A way of thinking about direct variation would be, say, an hourly wage. If someone makes $7 an hour, they earn $21 for working 3 hours, $28 for working 4 hours, and so forth. Inverse variation goes in opposite directions. A way of thinking about inverse variation would be, say, the time it would take a certain amount of workers to get a job done. Let's say it takes 36 hours to get a job done. 2 workers, it would take 18 hours. 3 workers, it would take 12 hours, and so forth. Of course, that's assuming that the workers are of equal value or work equally hard. Our last example looks more like the first one. Notice that the variables are going both in the same direction, and there is a detectable pattern here. As X goes up, so does Y. But 5 divided by 1 is 5. 15 divided by 2, though, is not 5. 15 divided by 2 is 7.5. And you'll find as you continue to divide, despite having that detectable pattern, you're not getting the same number over and over. So this last example would be neither direct nor inverse variation. Okay, here's an example of direct variation here. It says the amount of money M that Dan earns varies directly with the amount of hours H he works. Dan earns $96 in 8 hours. How much does he earn in 40 hours? Now, first thing I want to say here, when you have two variables that vary directly, a simple proportion will work. Okay, so the way I'm going to show you here may seem to be a little bit longer than a simple proportion, but by showing you this method, it'll help you understand the inverse variation model we're going to look at next. So as soon as you see varies directly, what we're going to do is write down M equals K times H. And the reason we're doing that is, if you remember from the notes, varies directly has your two variables, which often are Y and X. Here's M and H because they give us those letters. Set up in this format where one of the variables equals the other variable times something. Okay. Notice also that if I isolated K here and I divided the two variables M and H, I always would get the same value K, which is consistent with what we said earlier. I'm going to set up M equals KH. I notice that M for money, 96, is equal to K times the amount of hours he works, which is 8. Okay, so I just simply inserted 96 in for the money and 8 in for the amount of hours he worked. Now, naturally, the next thing you're going to do is find K. And we'll do that by simply dividing 8 here. And you'll get 12 to be K. K is called our constant of variation. If you were to divide the amount of money Dan makes by the amount of hours it works, you're always going to get 12 in this situation. So now we can rewrite the equation M equals 12H. Anytime you have an equation with more than 3 variables, what you want to do is find the value of that extra variable or variables. In this case, the extra variable would be K, because M is kind of serving as Y here, and H is serving as X. So anytime you write the equation of something, Y and X generally stay variables in the end product, but any other variable, we want to find their value. So we found K here to be 12. And the power of this is I can now find the amount of money that Dan makes if you give me the hours, or if you give me the amount of money he makes, I can find the amount of hours he worked. In this case, it's asking how much does he earn in 40 hours. So I can use this by just plugging 40 in for H and simply multiplying here to get $480. I do repeat, you can just simply set up a proportion. I'll do it to the side here if I have room. You could have said 96 is to 8. That is the amount of money he makes is the amount of hours he works, as X, which is the amount of money we're looking for, is to 40. And then just simply cross multiply here, which would be to take 96 times 40 and divide the result by 8. That does work in direct variation. But as you're going to see with inverse variation here in our next example, this process of finding K and then using the resulting equation will work for any situation here. Okay, we have one more example here. The amount of time T it takes to plant a garden varies inversely, that's important, with the amount of workers N that are present. It takes 6 workers 4 hours to plant the garden. How long would it take 8 workers? I'm sorry for the lack of the perfect handwriting there, but hopefully that's legible to you. When you see varies inversely, a simple proportion is not going to work here. We have to set up a little bit differently. We're going to take the first variable we see, which is our T. We're going to write it first. And if you remember from the notes, for inverse variation, it's not T equals K times the other variable. It's actually T equals K divided by the other variable. And the other variable here is N. So T equals K divided by N. So we're going to do the same thing here as we did in our last example. We're going to figure out what K is and then use that for this situation here where we wonder how long it would take 8 workers. All right, so we're going to take 4, which is the amount of time, and plug it in for T. We're going to take the amount of workers we have, which is 6, and put it here. And now it's just simple algebra to solve for K. We're going to multiply both sides by 6. And we're going to get K here to be 24. Okay, and what that allows us to do is to take 24 and plug it back into the original setup, and we get this very powerful equation, T equals 24N. And what that does for us again is allows us to tell one variable if given the other. The question here says, how long would it take 8 workers? Well, I'm going to take 8, and since we're looking for the number of workers, the variables here help. The number of workers will be N. I can just plug 8 where N is, and I get 3 workers. Now, always make sure your answers make sense. I now have more workers, so it should take less time. Okay, it would be very counterintuitive if I added workers and then suddenly it took me longer. That wouldn't make sense. 6 workers, it took 4 hours. I've increased the amount of workers, so now it should take me less time. Okay, that's the reason I added those extra workers. So I now have 3. Remember, when it says varies inversely, you cannot set up a simple proportion And to catch any common errors, just make sure your answer makes sense at the end. I do want to say hours here. I do want to put my unit there. 3 hours is how long it takes there.